Hi, Doreen.
Hi, Chad.
Taking a break from the physics lab?
Yeah, I'm actually thinking of explaining the Planck constant using my cup of coffee.
I'm curious. Try me.
Well, see, in classical mechanics, energy is continuous, meaning if I take my sugar dispenser, I can pour any amount of sugar into my coffee. Any amount of energy is okay. But Max Planck found something very different when he looked deeper. Energy is quantized or discrete, meaning I can only add 1 sugar cube or 2 or 3. Only certain amount of energy is allowed.
Not 2 1/4.
Exactly.
I see.
And same thing when this cup of coffee releases heat, like I draw it in here, the energy is equal to the Planck constant times the frequency of the radiation that carries the heat.
And your team has just measured the Planck constant, right?
Yes, we did indeed. This year we measured at NIST the Planck constant, and we found that H is equal 6.626 10 to minus 34 kilogram per meter square per second.
10 to the minus 34, so that's really small.
It is, and the uncertainty is very small too. It's 0.6022 10 to minus 34 kilogram meter square per second. And if you divide those two numbers, the accuracy of our measurement is 34 parts per billion. For example, to give an analogy, if you measure the distance between Washington, D.C. and New York, which is 230 miles, and I can tell you the distance to within 0.5 inches.
Wow. So now I understand the Planck constant better, thanks to Darina Haladad and her coffee.